Our lesson today will be on solving quadratics and associated word problems. So whenever we're trying to solve quadratic equations, we first need to put the quadratic equation in standard form. Which is ax squared plus bx plus c equals 0. Step 2 would be to factor the expression. Step 3 says set each factor with a variable in it equal to 0. So now we're going to use the zero product property to solve. Now the zero product property says if a times b equals 0, then either a equals 0 or b equals 0. So let's look at this a little bit further. If a times b equals 0, what would happen if a equals 0? Well, if a is 0, we have 0 times b, and 0 times any number is still 0, so it works. If a is some number but b is 0, a, whatever the number it is, times 0 will still be 0. So if a is 0, then that makes the whole thing 0. Or if b is 0, then the whole thing's 0. Now that or is important. We can't be both a equals 0 and b equals 0 at the same time. You can in certain situations, but most of the time it's or. So on our first problem, x times 4x minus 3 equals 0. Step 1 says set it equal to 0. Well, it's already equal to 0. Step 2 says to factor it. Check, that's already factored as well. Step 3 says set each factor with a variable in it equal to 0. So there is two factors, the x factor, and that has a variable in it, so I set it equal to 0. And then the other factor, 4x minus 3, also has a variable in it, so I set it equal to 0. Now the first one, x equals 0, is actually already solved, so I don't need to do any more. But the other factor is now a linear factor. It's now not quadratic because there's no x squared in it, it's just x. So I divide by 4, and I solve that using just my linear stuff. There's no x squared, so it's not quadratic anymore. So we get x equals 3/4, and this one was already solved, so x equals 0. So my answer is 0 and 3/4. Excellent. Next problem, x plus 3 times x minus 9 equals 0. Well, step 1 is already done for us. It's set equal to 0. Step 2 is already done for us. It's already factored. So we're going to jump down to step 3 that says set each factor with a variable in it equal to 0. So x plus 3 has a variable in it. I set it equal to 0. Or x minus 9 has a variable in it, so we set it equal to 0. So my two answers are -3 and 9. So if I were to plug -3 in here, this is a check, this is optional, I'm just going to show you this once. If I were to plug -3 in, we have -3 plus 3, -3 minus 9 equals 0. We're checking to see if this works. -3 plus 3 is 0, times -3 minus 9 is -12. Now I know this isn't 0, but I don't really care what it is because 0 times anything will get me 0. So that's why it doesn't really matter. As long as one of the factors is 0, then the whole thing is 0. Let's go on to the next problem. -3x squared plus 12x equals 0. Step 1 is make sure it's in standard form equal to 0. Check, that's done. Step 2, factor the left-hand side. So on this left-hand side, I'm going to use the factoring skills that I've been practicing. So look, step 1 is a GCF. I can factor -3 and an x out. So that gets me -3x squared divided by -3, x is x. Positive 12x divided by -3 is -4. Step 3 says set each factor with a variable in it equal to 0. So this -3x, because there's an x in the factor, I have to set it equal to 0. I'm also going to set x minus 4 equal to 0. And solve each of those linear terms. No x squared anymore, so these two factors are a whole lot easier to solve these two equations. So I'm getting 0 and 4. Now I could check that if I want, but I'm not going to check every problem. That's not required on this problem. On our next, we have 2x squared plus 7x minus 4. Step 1 is set it equal to 0. Yep, already done. Step 2, factor the left-hand side. So I'm going to factor, it's a no GCF on this problem. It's a 3-term polynomial, and because the 2 in front is not a 1, this looks like a harder trinomial. So I'm going to use guess and check. So my factors of A are 1x times 2x. My factors of C are 1 and 4 and 2, or 2 and 2. So I'm going to try 1x and 2x. It would not be a good idea to put 2 and 2 here, because that would mean that the two 2's are next to each other, and that would be a GCF other than 1, and that's not correct. So I'm going to try the 1 and the 4. Now, I am allowed to put the 1 and the 1 next to each other, because there is no GCF of 1 and 1 other than 1, and so that one is okay. I'm always allowed to put 1's next to each other. I just don't want to put two numbers next to each other that are the same, that are not equal to 1, or like bigger than 1, or multiples of each other. That won't work. Let's see. So I'm going to go ahead and try this. This one's probably not going to work. I don't really want a 2 and a 4 next to each other, because that means there's a GCF of 2 there. So it's probably not going to work. Let's just go ahead and check. Yep, 4 and 2 won't get you 7. So we already kind of knew that. So I'm going to try 1x and 2x, and let's put the 4 across from the 2, see if that works. So this gets us 8x and 1x. Using 8x and 1x with one of each sign, because the 4 is negative, that means I have to have one of each sign. So I put a positive on the 8 and a negative on the 1. So this factors into x plus 4 and 2x minus 1 equals 0. Then I set each of those factors equal to 0. And then I can solve those. So subtract 4 on the first one. This is now linear, which is much easier to solve. So I'm getting x is equal to negative 4 and x is equal to a half. So those are my two answers. On our next problem, x squared plus 36 equals 13x. This does not equal 0. So the first thing I want to do on step 1 is put it in standard form by moving the 13x to the other side. You could just pick up the 13x and put it on the left-hand side and just change its sign, or you could subtract. Either way, you're still going to get x squared minus 13x plus 36 equals 0. Next, I'm going to factor. I have a no GCF here. Step 2, how many terms? I have 1, 2, 3 terms with a leading coefficient of 1, which means it's an easy trinomial. So when I factor this, I'm going to have an x and an x in the front. I'm looking for two numbers that multiply to 36, yet at the same time add to 13. My factors of 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Because the 36 is positive, I'm either going to have a positive times a positive or a negative times a negative. In this case, I need to add to negative 13, so it looks like both of them are going to need to be negative. And I'm getting negative 4 and negative 9. Now I set each of those factors equal to 0 and solve. So my two answers are positive 4 and positive 9. As a note, these can be in either order. On our last problem here, I don't have this in standard form, so I need to distribute and combine like terms to get it into the right form. So I have 36x squared plus 18x minus 10x equals 8x plus 25. Now the 18x and the minus 10x on the left-hand side can combine like terms to get 8x. Now I need to get one side equal to 0. So because the x squared is on the left, I prefer my first term to be positive, and it's already positive on the left. So I'm going to go ahead and move all the terms from the right side to the left side by adding or subtracting to get their opposites. So that gets me 36x squared. We have positive 8x minus 8x, that adds to 0, minus 25 equals 0. So all of those steps was just to complete step 1, which said put it in standard form, make sure it's equal to 0. Step 2 says a factor. This is a no GCF, but it is a difference of squares. So to get 36, I take 6x squared, and to get 25, that's 5 squared. So that's 6x in the fronts, 1 plus and 1 minus, and 5's in the back. So 6x plus 5, 6x minus 5. Set each of those factors equal to 0. My first one, I get x equals negative 5/6. And x equals positive 5/6. So negative 5/6 and positive 5/6 are my solution set.